Hi, my name is Jennifer Huber, and I'm going to take the next few minutes to discuss the differences between RFID, NFC, and BLE. And if you're not entirely sure what these acronyms stand for, that's okay. Just hang in there and you will after this video is completed. Clearly, not all wireless is the same. Just because a thing doesn't require wires to do something doesn't mean that they operate in the same frequency, on the same channels, use the same data transport mechanisms, and loosely described, BLE, RFID, and NFC could be called wireless technologies because they all operate by sending data without using wires. But there's a vast difference between the three different technologies. RFID is something that you've definitely come across. You've come across the little inlay tags, the little white paper stickers that are placed inside DVDs or CDs or any kind of merchandise that is in a store. And that's an RFID solution to deter theft. The thing that you walk through when you come through a store, this big thing that may be covered up with advertising, these are everywhere in all retail environments. There is one of these at the entrance, and which is also the exit of the store. This could also be described as an RFID exciter. And I say that because this device here triggers the tag to send out a chirp, a beacon, to react to being triggered. And that reaction, that data that's sent from the tag when it is excited or triggered by this device here, this RF exciter, then is what turns on the alarm to let the cashiers or the store security know that a device has left the store that was not deactivated, meaning it's probably something being stolen. So RFID tags can come in all different kinds of shapes and sizes. They can look like key tags. They can be little glass tubes. They can look like employee badges. And the types of devices that you're going to come across most frequently are the passive RFID tags. Passive RFID tags do not have a battery, and they only have a single antenna, meaning they can only transmit data on a low frequency network. An active RFID tag typically has a battery, and it typically has two antennas in it. One antenna would be triggered by a doorway exciter to know the exact location of a tag. Devices that are tagged with active RFID tags are typically not 802.11 devices. In this example here, we can see this cart has been tagged with an RFID tag, and as it passes through this doorway has an installation of an RFID exciter so that this tag will send information when it passes through this exciter, and that information from this active RFID tag is sent across the 802.11 wireless network. So the tag is triggered on the low frequency, and the data that it sends out into the air, if you will, the data that's transmitted from it when it's excited by this exciter, is sent across the 802.11 2.4 gigahertz frequency, and that is picked up by the wireless infrastructure that is also installed in this environment where the active RFID deployment is deployed. A Bluetooth low energy device is a little device, a little plastic housing that holds a battery, a little RF chip that transmits on Bluetooth frequencies, which is in the 2.4 spectrum. And all this device does when it's deployed is send out information at a predetermined rate in the area where it's installed, and it just transmits its universally unique identifier. It transmits a UUID. So that's all a Bluetooth beacon does. The beacon doesn't do anything, like nothing happens until the end user enters the environment with their smartphone, with their customer loyalty app, whatever the app is that's going to be able to do something when it detects a UUID being broadcast in its environment. Then when the smartphone detects the Bluetooth beacon telling it its UUID, that information can then be relayed through the third-party app, the application that's on the end user's smartphone. That information can then be sent to the customer loyalty backend database, and then based upon that information, an actionable thing can happen. The end user can receive a coupon, they can receive points for coming into the store or being in the location. Something can happen based upon that end user coming in with their smartphone with a data connection. So either the the cell phone connection, the cellular connection of the end user smartphone, or they would have joined the store's guest Wi-Fi network. There needs to be a transport mechanism to get that information back to the server backend database before anything can happen to the end user's device. So let me repeat this again. A person comes into the store. Retail is the simplest example for a BLE beacon. Person comes into the store, they have the customer loyalty app already installed, they've logged into it with their username and password. The customer loyalty app may automatically onboard this person to the guest Wi-Fi so that they don't have to accept the EULA, they don't have to click through anything, they just are automatically onboarded to the guest Wi-Fi. Even in this example, even if they didn't have a guest Wi-Fi, the data network from that cell phone would be used to transmit the information from the phone saying, I heard UUID, blah, 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 blah. And that data would go across the internet into the back-end database, so the CRM database of the store that wrote the app in order to put two and two together. I see this MAC address, and then the back-end database could say, oh, that's our frequent shopper, XYZ so-and-so, and they left this device or this thing in their cart and they didn't complete their checkout. Send them a coupon to see if we can get them to complete that transaction. So Bluetooth beacons are just a device that's installed that sends out data into its local area. It just beacons information. Nothing happens with that information if the end user comes into the store and their smartphone has their Wi-Fi off or their Bluetooth off. Okay, so if the Bluetooth is off on the phone, their device is never going to detect the UUID being beaconed. If the user comes into the store and they have a weak cell phone signal, there's not going to be a transport mechanism to send that information up to the internet that the app on the phone detected a UUID that it knows about. Bluetooth Low Energy operates on the 2.4 gigahertz frequency. It is a frequency hopping device, so that means that it doesn't adversely affect any one 802.11 channel. Because of the nature of its operation, it hops from channel to channel to channel. So therefore, it does not adversely affect any one channel for any extended length of time because it hops from frequency to frequency. Near Field Communication, or NFC, is a technology that just requires two devices to be within proximity of each other. And to elaborate on this, if you've ever worked somewhere where you've had an employee badge that had a door lock system installed so that you could use your badge to get in areas, maybe get into a data center, get into a building or a department of a building, that is using NFC. You hold your badge near the proximity reader like you see in the photo here to the right, and either the door opens or it does not based upon entries in your database about whether or not the employee is allowed access or not allowed access into that area. That's a very common NFC example that has been around for a really long time. Newer uses of the technology are creating interactive, two-dimensional signs or posters where you can hold your phone up to the poster and either receive the restaurant menu, or it will launch a feedback form in order to provide feedback to a given situation or a given customer or whatever the use case might be. There's also been marketing campaigns that were launched to place your phone here to receive a free download of a song, a free download of an app, and Near Field Communication operates over the 13.56 megahertz frequency. The most recent uses of NFC have been the advancements that have been made through using Apple Pay or Google Wallet or Android Pay with your smartphone that is NFC enabled. It has an NFC chip in it, so therefore you can use that smartphone to complete transactions at retail establishments, much in the same way that you would just hold your employee badge up to the proximity card reader. It's the same type of technology. The use case is just a little bit different. So key takeaways. A Bluetooth beacon is a device that's battery powered that's designed to simply transmit a universally unique identifier. The Bluetooth receiver, smartphone, is the device that does something with that universally unique identifier information. The range of a Bluetooth device is quite small. It does operate in the 2.4 gigahertz frequency. The distance between a Bluetooth beacon and the receiving device, meaning the smartphone, is categorized into 3 distinct ranges. Immediate is a few centimeters away, near is within a couple of meters, and far is greater than 10 meters away. Standard Bluetooth beacons have an approximate range of about 70 meters. An active RFID solution is one in which non-Wi-Fi devices are tagged with an active RFID tag. In this example, it's an infant that has an active RFID bracelet attached to the infant so that we can trigger an alarm if the infant is removed from the neonatal unit of the hospital. The alarm is triggered when the tag passes through the doorway that is configured with an exciter. The exciter triggers the tag beacons over the wireless network, and therefore actionable information can be taken to call security, to sound an alarm, to do something because a tag has passed through an exciter. NFC or proximity card readers can do things like grant access to physical doorways. It can lock and unlock doors. It can enable you to complete cashless payment transactions all through the proximity of a device to the NFC reader, meaning a badge to the proximity reader at a door or your smartphone to a proximity reader at a retail establishment. Active RFID tags are typically deployed to track expensive non-Wi-Fi devices. And I say expensive because your typical active RFID tag list price is about $75. So think medical equipment or any kind of equipment which may require periodic servicing, therefore needing to find the device within a large building. Think expensive things that shouldn't move. Say a digital media signage can be tagged with an active RFID tag, and you can trigger the tag to start beaconing when it moves, and therefore you know if a thing is moving that should not be moving, you can take action to find out why it is moving. So think employees, students, and infants in use cases in which you would want to know whether or not all employees or students have left the building. Think fire alarm activation. You can make sure that the building has been completely cleared of people, because the employee badges or the student badges are also RFID tags. If you wanted to secure the neonatal unit of a hospital, you could tag all of the infants with active RFID tags and then create business use cases so that if a tag was triggered, you could have security deployed to that floor to determine why the tag went through a doorway that it shouldn't have, or the infant went through a doorway that it shouldn't have. Passive RFID tags are typically deployed to track inexpensive non-Wi-Fi devices. And I say inexpensive devices because passive RFID tags, if purchased in large enough quantities, can be as inexpensive as a penny a piece. So think inventory of pallets where the pallet is piled full of boxes that need to be inventoried quickly and accurately. And if you have the pallet tagged with a passive RFID tag that contains the inventory list, then you can just scan that tag on the pallet instead of having to scan a barcode for each box that is part of the pallet. BLE beacons are typically deployed to engage with an end user via their smartphone app when they enter into a predetermined area of interest at a customer location. You can also think about interactive displays at a museum. A museum may have partnered with a third-party app developer to develop an application for download and use at their museum. As you approach points of interest within the museum, the application could then launch additional audio feeds or visuals or something to create a more robust interactive experience for the end user that's in the museum to see the things that are on display. BLE beacons can also be deployed densely enough to enable you to order refreshments at your seat when you go to a stadium to watch a game or a concert. The stadium has an application that you download. You can log into it and tie it to some form of payment, and thereby can order beer, food, refreshments to come to you instead of you going to the refreshment stand at the stadium. There's enough location information in the area, meaning access points that can detect your MAC address or BLE beacons that can detect your location so that you can have the food come to you. Near-field technology is typically deployed to enable a cashless payment, at least nowadays. In previous iterations, the most common was to allow access to locked doors. So think Apple Pay, Android Pay, Google Wallet, think proximity badge readers, and think interactive signage in order to interact with the end user's smartphone in a way that wasn't typically available with just a simple two-dimensional sign. Thank you for taking the time to watch this video. I hope that it was helpful. I hope that you learned something from it. Thank you very much.